Hello everyone, we are 10 teams and our project is Galaxy Soho. First, let's review what we published last week. Last week, we introduced the Siamese structure design of Galaxy Soho Center. Next is the list of contents this week. This week, we will introduce the construction technology of oval tower steel bridge of Galaxy Soho Center, including 1. Installation method selection, 2. Steel connecting bridge hoisting process, 3. Steel connecting bridge measurement, 4. Support systems design, 5. Steel connecting bridge welding, 6. Summary, 7. Study plans. Number 1. Installation method selection. The installation of the steel bridge needs to be completed with a crawler crane. Crawler crane is a boom rotating crane that's used crawler working. The crawler has a large grounding area, good passability, strong adaptability, and control with load. The truss is segmented according to the lifting performance of the crane, and the load-bearing frame is installed at the segmented point to meet the installation of high altitude paths. Steel connecting bridge hoisting process. The components of the project are heavy and long in length and are constructed with 100 T lifting equipment. 2.1 Installation of steel bridge in the first stage. Taking the bridge BR1SI example, the first stage of hoisting is mainly the installation of the primary and the secondary beams on the L3 floor. The steel beams are temporarily fixed. The upper and lower frames are fixed with connecting planes and hair strings bolts, and the wires are fixed with side springs and high strings bolts. After the overall installation is completed, and the welding is carried out step by step to reduce the impact of welding shrinkage on the installation occurs. 2.2 Installation of the second stage steel bridge. The steel bridge structure of the project used the facade as the main stress system, and the connecting beams between the planes and are the secondary members. In order to meet the hoisting requirements of crawler cranes, the second stage of installation is mainly installed on the inner facade to ensure for the stability of the facade steel members. Temporary diagonal braces are set on the inner sides of the facade steel members. The steel column and the steel beam are temporarily fixed. After the overall installation is completed, the welding is carried out step by step to reduce the impact of welding shrinkage on the installation accuracy. The steel column and the steel beam are temporarily fixed. After the overall installation is complete, the welding is carried out step by step to reduce the impact of welding shrinkage on the installation accuracy. In the second stage, when the steel bridge is installed, the heaviest component is 20 tons. The working range of the 100T crawler crane is 16 meters. The boom length is 58 meters, and the lifting capacity is 21.6 T. The lifting analysis is shown in Figure 6. 2.3. The third stage steel bridge installation. In the third stage of the steel bridge, the outer facade and the connecting beams between the steel members of the inner facade are installed, and the installation is carried out layer by layer. Figure 7 shows the effect after the installation of the steel bridge. Steel connecting bridge measurement. The steel bridge of this project is a suspended structure with a higher distance from the ground. The structural floor slabs on both sides of the bridge are used as the operating surface for the measurement work. Based on the side reference point, the axis and the elevation are measured to the L5 structure floor of the structure on both sides of the bridge, and the steel bridge axis is controlled, and the point position is determined using a Tato station for measurement. Before installation of the steel bridge, measure and release the axis and the control position of the steel beams on the supports on both sides and the top of the support to ensure the accuracy of the initial installation, while ensuring the correct installation elevation and axis position. The midspan vertically lateral bending vector height and the midspan camber of the main steel beam should be observed during the installation process.
4. Support system design. The net height of the steel bridge in the low area of the project is close to 27 m from ground, and the weight of a single bridge is close to 500 T. Because the conventional steel pipe scaffold cannot meet the load bearing requirements, the steel pipe supports used in the foundation pipe supports is used for reference. The bottom of the support system is located on the original ground. In order to reduce the impact of concentrated load, after calculation, a 2 meter times 2 meter times 0.5 meters reinforced concrete block is made at the bottom of each support to avoid the load caused by the support system. The settlement broken and removed after the construction of the steel bridge is completed. The welding difficulty of this project lies in the need of butt welding of thick planes at winter temperatures. So flame heating is used for the thick plate welding to preheat before welding and heat preservation after welding. For the butt welding of the main steel beam and the butt welding of the main and secondary beams, a simultaneous and symmetrical welding sequence is adopted to control the welding deformation and ensure quality. Weld the facade steel components first. That is, the main steel beam is welded first. Then the steel column is welded. And finally, the plain connecting beam is welded. 6. Summary. In this project, reasonable installation method and flat butt welding method were adopted in the construction of low-zone steel bridges. The reasonable design of the support system reduced the use of large-scale lifting equipment and ensured the overall construction period of the project. 7. Study plan. In the future, we will introduce the construction structure, construction process, construction difficulties, and green building.